Hello, welcome to the module of data ingestion and management, and in this video we are going to learn about the benefits and challenges of Lambda architecture. In this video we are going to discuss first on an overview of Lambda architecture, then we would be defining about the Lambda architecture concepts on Azure, we would be talking about then the benefits of Lambda architecture, and followed by we'll be discussing about the constraints on the Lambda architecture. So let's get started. The Lambda architecture, if we have been defining about that, it involves the concepts that towards the building of the services that enabling like efficient data processing on the massive data set. So typically once ever this Lambda architecture, it involves a three layer of the data analytics architecture which has been designed to run the analytics over the large data sets. The architecture is being exist to handle the high latency analytics while presenting a near real-time view of the system. There are three major components exist to balance the high latency of the batch analytics with less complete data from the streaming analytics. The batch layer, it has a master data set like which could be an immutable append-only set of raw data and the batch views. The serving layer, it has also going to have the batch views for faster queries. The speed layer can actually compensate for the processing time, and the queries can be both merged including the results for both the batch views and the real-time views. Now if we having talking about a quick lap around or on glimpse of batch and the real-time streaming data platform. So basically the data sources, typically if we having talking about the data sources like all these big data solutions on the cloud, that includes the data ingestion either coming from the application data stores, the relational databases, the static files that could produced by the apps or real-time data sources like IoT devices. So typically Lambda architecture enables like efficient data processing of massive data sets. Lambda architecture, since it uses the batch processing, stream processing and a serving layer to minimize the latency involved in querying the big data. So if we having talking about that this Lambda architecture, what does it consist of? The basic principles of Lambda architecture having consist of basically that the three layers. First of all the data in the Lambda architecture has been pushed into both the batch layer and the speed layer. The batch layer, it has the master data set that consists of the immutable append-only set of raw data which pre-computes the batch views. The serving layer that has been also consist of all the batch views for faster queries, and the speed layer that compensates the processing time to the serving layers and deals with the recent data only. All these queries could be then answered by merging the results from the batch views and real-time views, or we can ping them individually. So Lambda architecture on Azure, since it consists of both the batch layer as well as the speed layer, the batch layer that is basically consists of the end-to-end data ingestion services like through Azure Data Factory, the structured data could be ingested to the Azure blob storage or Azure Data Lake storage, and from there the data could be transformed through Spark streaming, that is to Azure Databricks, and could be just being connected through the change feed connectors to Azure Cosmos DB and can be moved into the various consumer layers or the consumption layers. And similarly, like for the batch data processing scenario, the data from the Azure Data Lake storage could be further enhanced through the Polybase support through the analytical data stores like Azure SQL Data Warehouse, or through the various analytical dashboards the data could be prepared into, so that altogether it can handle like this massive quantities of the data that can take these advantages of both the batch data and the stream processing layer. So Lambda architecture on Azure overall can help to enhance the speed and the business challenges since both the batch and the serving layer in this Lambda architecture can be loaded into Azure Cosmos DB, and this is where like the master data set that could be it could involve like the immutable and the append-only set of data. So the data after that is getting transformed, it could be loaded into like a NoSQL databases or an analytical data stores as part of the batch layer or the serving layer methodologies, or the data could be built into the speed layer itself, like it can involve into like the change feed or like near real-time streaming operations. The data could be processed in between that is the batch and the speed layers. So Lambda architecture on the Azure Data Platform, it has also got the ability to process the data at high speed in a streaming context, and which has been necessary that's to also being processing the data on the operational needs, such as like transactional processing and for the real-time processing. The batch processing also involves like this massive amounts of data, and the related correlation and aggregation has been supported for this important business reporting. Now let's talk about some of the benefits of Lambda architecture. The batch layer, which is being responsible for managing this historical data with the fault tolerant and the distributed storage layer, and it has got to be responsible to ensure like the lowest possibility of the errors even if the system crashes. So the batch layer, since it has been consist of the master data set, so it just being involves into like immutable and append only set of the raw data that could be stored into the kind of NoSQL databases or the batch based storage, just ensures that the lowest possibilities of the errors even if the system crashes. And the data processing techniques also involves like it is being capable to deal with this huge amount of data in an efficient manner. It can be considered like as a real-time data processing architecture, and it uses both these functionalities of the batch layer and the stream layer, and can keep like adding this new data to the main storage while ensuring that the existing data will remain intact altogether. Now in terms of constraints on Lambda architecture, we can talk about that since the Lambda architecture can becomes like it is being complex due to the involvement of the comprehensive processing, though in real time we can see that Lambda architecture could be utilized for the various use cases. If we just been defining about like many of the use cases that could involve like the log analytics solutions for the high scale websites or for the large sets of the non-uniform hardware diagnostics analysis. So the speed layer just being processed only the current data and it has been produced from the thousands of machines using the Storm or the Spark framework. So the batch layer could be analyzed from this entire data set. It can deal with this multiple different encodings from the historical and the current deployments of the analytics softwares, and it can be implemented on the Hadoop MapReduce. So both the batch layer and speed layer could involve like to produce the output data to a NoSQL database clusters like Azure Cosmos DB or MongoDB or Cassandra, and can build out the simple downstream services like a consumption layer through the various analytical dashboards like Power BI or simple web apps. So as part of the constraint wise, likewise we can say that the Lambda architecture sometimes can become very complex due to the complex coding overhead due to the involvement of the comprehensive processing. It can also involve like reprocessing like every batch cycle, which is not being beneficial in the certain scenarios. It could also involve like a data that's to be modeled with the Lambda architecture, since it involves like very difficult that's to migrate or to reorganize itself. So these are the various benefits as well as challenges that involves while in incorporating this Lambda architectures. And also some of the significant disadvantages of the architecture is that since there are three separate layers that has been necessarily being coupled, so the solutions which has been built by using the Lambda architecture are generally complex, can be quite fragile, especially during the earlier iterations. So having both the batch and the stream layer generally could be implemented in the different technologies. Like we can interpret the same dataset to produce the similar and complementary result set. We can often end up with multiple implementations of the same code. Thus results in the extended testing cycles and increased complexity due to the deployments. So in this real-time experiences wise, this kind of code duplication is the root of the most of the problems that could be experienced in this architecture, as the bug fixes or the new data formats that could be implemented in two or more items, and it can get out of sync. Now during this maintenance phases of the Lambda architecture, we can also risk like implementing updates in one layer and missing another layer. Another important disadvantages of this Lambda architecture pattern is that it can be made somewhat obsolete due to the stateful streaming technologies, and that's why the Kappa technologies are also being evolving over the time. Kappa architecture just also projects and can meet some of the requirements with less complexity, less code duplication, and simpler operations. So in this video end to end we discussed about the benefits and challenges of the Lambda architecture. I hope this video has been informative for you, and I look forward to see you in the next video. Thanks for your time.